Hi guys, we're going to start chapter 7.2 notes, which is over similar polygons. So let's first start with the key concept about similar polygons. Two polygons are similar if and only if their corresponding angles are congruent and their corresponding side lengths are proportional. So let's look at the example and diagram. We have ABCD, so this first polygon, similar to WXYZ. Well, all of their angles have corresponding angles, and we can see that by the number of loops on each one. So we have a 1, 2, 3, 4. We also know that their corresponding sides have a proportional length. For example, if we wrote each side over the other one, so 15 over 5, 18 over 6, and 12 over 4, and 21 over 3, all of them are going to reduce to the number 3. So that means ABCD is 3 times bigger than WXYZ. Okay, so let's go ahead and look at the first example. First, we have to list all the pairs of congruent angles and write a proportion that relates the corresponding sides. So first, we have triangle FGH is similar to triangle JKL. Well, based off the location, that tells us what angle is going to be congruent. So angle F is congruent to angle J because they're first. Angle G is congruent to angle K because they're second. And angle H is congruent to angle L because they're third. Now let's look at the corresponding sides. Well, FG is going to be proportionate to LK. So FG is proportionate to LK. GH is going to be proportionate to KJ. So equals GH, KJ. And then HF is going to be proportional to JL. Okay, and that's all. That's all it's asking for us to do. Okay, let's go ahead and look at the next example. So, Kuma wants to use the rectangular photo shown as the background for her computer desktop, but she needs to resize it. Determine whether the following rectangular images are similar. If they're similar, write a similarity statement. So first we have to look at corresponding angles. Well, since all these angles are right angles, because it is a rectangle, then we already know that all the angles are similar because all of them are right angles. So all angles are congruent since they are 90 degrees. Now we have to compare the corresponding sides. So we have HG over ML, which is 14 over 15, and then GF over LK, which is 12 over 12. So this first one simplifies to, hang on guys, I'm looking at the wrong problem. We're comparing this little guy to part A first and then part B. So this is A. My bad. Let me rewrite that. The first statement is still correct though. So we have DC over HG. So DC is 10 over 14. And CB over GF, which is 8 over 12. So this first one reduces to 5 over 7, and this second one reduces to 2 over 3. 5 over 7 is not equal to 2 over 3, so we can say that they are not corresponding. So that means A would not be a good one. Let's look at B. The first part in B is going to be the same. Now let's look at the second part. So we have DC over ML, so 10 over 15, and CB over LK, 8 over 12. So 10 over 15 reduces to 2/3, and 8 over 12 reduces to 2/3. Since 2/3 is equal to 2/3, then that means they have corresponding sides. So that means they're going to use this one. So that means B is correct, but A is not correct. Okay? Let's look at example 3. Okay. Example 3 says find X and find Y if these two polygons are similar. So since they are similar, what we're going to do is we're going to, in order to find X, find the side where X is at. Well, since X is right here, that means we're definitely using this side. And then we just have to use a different side as well. So let's use this one and this one. Because remember, they're flipped, so this is reflected. So we have to use those ones. So that means we have CD over WY is equal to DF over YZ. Well, CD is 9, WY is 6, DF is X, and YZ is 10. So if we cross multiply, we have 9 times 10 is equal to 6x. 90 is equal to 6x. If we divide by 6, we get x is equal to 15. Perfect. Now let's do the same thing to find y. So we have CD over WY is equal to FA over ZV. Now we're using corresponding sides that relate to the variable y, which is right here. So we have 9 over 6 is equal to 12 over 3y minus 1. So let's cross multiply. So we have 9 times 3y minus 1 is equal to 12 times 6. So if we distribute this in, we get 27y minus 9 is equal to 72. Add 9, we get 27y is equal to 81. Divide by 27, we get y is equal to 3. And that's our answer. Let's look at this theorem. It says the perimeter of similar polygons. If two polygons are similar, then their perimeters are proportional to the scale factor between them. So what this means is that if we add all the sides of one polygon and divide it by all the sides of the second polygon, then what we should get is the proportion of each side. Okay, so let's look at example 4. This is going to be our last example for 7.2. So it says, if these two polygons are similar, find the scale factor of each polygon and the perimeter of each polygon. So the scale factor is going to be CD divided by RS. So CD over RS. CD is 4 right here, and then RS is 3. So then that means the scale factor is 4/3. Okay, now we need to find the perimeter. Well, since BC is congruent to AB and AE is congruent to CD, the perimeter of ABCDE is going to be this. So look, this has a little line, so this is also 8. This has 2 lines, so this is 4. So that means ABCDE is going to be 8 plus 8 plus 4 plus 6 plus 4, which is going to be 30. And then PQRST, so this is 3, and these ones, oh, I see. So do you see how these are missing? So we don't know this one, or this one. Well, in order to find that, we're going to take the perimeter of the first one, and we're going to create a proportion. So we had 4/3, which was our scale factor, is going to be equal to 30 over x, because we're trying to find the perimeter of PQRST. So if we cross multiply, we get 4x is equal to 3 times 30. That's 4x is equal to 90. Divide by 4. We get x is equal to 22.5, which is going to be the perimeter of PQRST. Okay. And that concludes the notes for chapter 4.2.